In the historical part of the planetarium, there is a traditional style museum named after the legendary patron of astronomy, the sky muse Urania. The museum's rooms are located in 2 levels. The floor area is more than 1,000 square meters. What is the first level of the museum now served as the basement in the old days, and the second level used to be the lobby. In the 2003-2004, the planetarium building showed a growth of 6 meters in 2 months. The memento of that event is the 6-meter hoisting pillar used for elevating the building is behind the glass now. The displays of the first level are devoted to the history of the planetarium, the development of the science of astronomy, and the methods of studying the Earth and the outer space. In the middle of the room, we see the astronomer, a scholar learned in all sciences of the early Renaissance. The astronomer is pondering over something in his study. Who knows? He might be thinking over the greatest secrets of the universe at this very moment. In the back of his study, you may see the first model of the celestial sphere. It is called armillary sphere. It is one of the ancient astronomical tools. It is with it that celestial goddess Urania is usually depicted. Invention of the armillary sphere is traditionally attributed to geometer Eratosthenes of the ancient Greece, who lived in the 3rd century BC. With the help of this device, astronomers of the past ages found equatorial and ecliptic coordinates of stars and planets. Later, armillary sphere was used as teacher's aid for the study of the main circles of the celestial sphere. Equatorial sundial is an ancient device for knowing the time of the day by the sun. Sundial presumably is one of the oldest scientific instruments that survived till our time unchanged, and that may be the first case of man applying his knowledge of celestial bodies' movements to practical matters. Above the head of the astronomer, there is a star globe, a big black metal ball with a lamp inside. If you look closely, you'll see a lot of small holes of different sizes. These twinkling points correspond with the positions of stars on the celestial sphere. The ancient star globe is the prototype of the modern planetarium projector. In the evening, when the lights are switched off, the globe turns the ceiling and the walls into an artificial star-studded sky. On the pillars of the study, there are old engravings dealing with astronomical subjects, which tell us how the men of the 16th, 17th centuries imagined the structure of the world. These engravings show a model of the celestial sphere, the worlds of the solar system planets, and different celestial phenomena. In the glass cabinets all around, old astronomical books, star maps, and sky atlases are displayed. They offer us a chance to get acquainted with the library of a scholar. One of the central cabinets is a modern virtual library. With the help of such a multimedia sensor device, one may learn the contents of the books in the cabinets and have a better look at the illustrations. The star globe of the outstanding Polish astronomer Jan Hevelius is displayed in the traditional-style Urania Museum. It's impossible to pass over this great golden globe, on which the constellations known in the 17th century are depicted. There are 1,564 stars from Jan Hevelius' star catalogue, which he made in 1687 with the help of his sextant of his own making, marked on this globe. All these stars, visible to naked eye, are comprised into 54 constellations. Picturesque forms Jan Hevelius attributed to the constellations became canonical and are well known to many people. Even now, the constellations are depicted as they were first drawn by the Polish astronomer. To the right of the entrance, there is a section on the history of the planetarium. Rare photographs, documents, books, pieces of the old stained glass windows, and models of spaceships. All these unique exhibits illustrate outstanding events of the complicated history of the Moscow Planetarium from 1929 up until now. The honorable award that was bestowed upon the Moscow Planetarium on its 50th anniversary, the Order of the Red Banner of Labor, is also displayed in this section. Here we have two very striking historical exhibits, the two previous planetarium mechanisms. Their production serial numbers are somewhat alike, 13 and 313. What is a planetarium? Planetarium is the name for a projecting device with the help of which one can, whatever the time of the day or the weather, project on the dome screen artificial star-studded sky. Traditionally, the whole complex that houses such a projector receives its name and is also called planetarium. The projector, a complex optical mechanical device, was invented in 1923. Walter Borsfeld, a German physicist, engineer and architect, succeeded in creating the first device. Both our devices, Planetarium number 13 and Planetarium number 313, were manufactured in Germany by the world-famous optical firm Carl Zeiss Jena. These very devices had been displaying artificial night sky on the dome screen of the Moscow Planetarium in different periods of its history. The first device is Projector Planetarium number 13, installed in 1929. It was the 13th device of the kind in the world. Unfortunately, not all the components of the machine survived. The surviving parts, two black balls with shining breastplates around the lenses, now displayed on the stand, look like some mysterious objects from the outer space. Originally, the projector had the shape of a dumbbell, the two big star balls, which had diameter about 75 cm each. One ball projected the stars of the southern hemisphere, the second projected of the northern. All in all, there were more than 6,500 stars projected on the screen. Each of the star balls contains 16 projection lanterns. On the surface, we see only their lenses. But if we look inside, we may see the construction. We see a huge, powerful 1000-watt lamp that gives light for all the projection lanterns. There are as many lenses as there are lanterns, 16. The 13th machine of the Zeiss second planetarium model had been displaying star-studded sky for nearly 50 years. In 1977, it was replaced with a new, bigger 6th model device that was manufactured specially for Moscow. Projector number 313 was the first planetarium in the world to have automatic control system. As to the appearance, there was little change. Like its predecessor, it had two big star balls connected by the framework, motors, projectors. The difference was in the quality, the most advanced optics, electronic stuffing, additional display options. All that allowed creation of something quite brand new for planetarium shows: automated audio-visual programs. Before that, stars cast on the dome screen looked like circles of different diameter. With that new device, the look of the artificial star-studded sky changed. Now it became in fact undistinguishable from the real thing. Today, the device installed in the Grand Star Hall is the state-of-art projector, Universarium M9. It continues the predecessor's traditions, but on a new technological level. Amazing, but the serial number of the new Star Sky projector is 613. For many centuries, knowledge of astronomy not only enabled man to understand the ways of the universe, but also helped him in his everyday life, to measure time, for example, or for orientation purposes. On the first level of the traditional Urania Museum, there are displayed in the glass cabinets ancient astronomical tools from the planetarium funds, beginning with the sundials and the simplest angle measuring tools, and up to the universal tools and telescopes. Take special notice on this sextant. This astronomical tool is used to measure angles between any two visible objects. Usually, sextants are used for measuring the altitude of a celestial body above the horizon, in order to learn the terrestrial coordinates. For example, measuring the altitude of the Sun at noon, one can calculate the latitude of a place. The scale of sextant has a length of 1/6 of a turn, or 60 degrees. Hence, the name of the tool, sextans, sextantes, means 1/6 in Latin. Angle measuring tools developed, and there appeared theodolites, precision instruments for measuring angles in vertical and horizontal planes. The basic principle of theodolite measurements is combining measurements of vertical and horizontal angles. Theodolites became widely spread in astronomy, in surveying, in engineering. Therefore, there are so very many different kinds of this instrument. Those used for meteorological purposes, by geologists, for geodesic surveys, optical theodolites. In geodesy, for example, they use theodolites to measure great distances on the surface of the Earth. The most important astronomical instrument for observing celestial bodies is the telescope. Here we have a 19th century reflector telescope of the Doland manufacture that has the 4.5-inch main mirror. John Doland, the English optician, and later his son Peter Doland, produced telescopes on commercial scale since 1789. A lot of interesting discoveries were made with the help of Doland telescopes. In 1761, Mikhail Lomonosov, while observing Venus transit across the disk of the Sun through Doland telescope, proved that this planet has atmosphere. One more interesting exhibit, a 1:10 scale model of the biggest in Europe reflecting telescope, Shine Mirror Telescope. This telescope is named after the author of the concept, Grigory Abramovich Shine, member of the Academy of Sciences. Shine's Mirror Telescope is the main instrument of the Crimean Astrophysical Observatory. This universal tool, equipped with a wide range of devices, was designed to meet requirements of different astrophysical tasks. In front of the Shine Mirror Telescope model, we see a small spherical mirror that helps us to demonstrate how the image of a celestial body is formed at a focal plane of the telescope. In the history of telescope making, the invention of glass mirrors was crucial. It opened a new era of the outer space exploration. The topic of astronomical tools usage is continued by the marine corner, which is styled to resemble a ship. In the glass cabinets you may see geographical and star maps, as well as the instruments necessary in sea voyages: sextant, marine chronometer, barograph, spyglass, and boat compass. Knowledge of the star sky, as well as instruments like these, were absolutely necessary for the seafaring man, especially in the age of discovery, that made our world wider and more interesting. The second level of the Urania Museum is what used to be the lobby of the Moscow Planetarium. What a grand view! The far corners of the universe, the world of celestial bodies. Huge stained glass windows open for us mysteries of the outer space. And on this marble ramp there is a scale model of the solar system, with the half spheres of the planets and the shining sun. There's also a wonderful collection of relief globes. Those of the Earth, the Moon and Mars are relics of the Soviet epoch. But the globe of Venus was made quite recently. It was based on the modern digital model of the planet's relief. They have something in common, our nearest space neighbors, but each one is unique in its own way. Bleak solid moon with its dark seas, light continents, and craters of different sizes. Red mysterious Mars with gigantic volcanoes, endless labyrinths, and polar ice caps. Enigmatic Venus without its cloud cover, with its petrified flows of volcano lava, high plateaus, and whole highland countries. And of course our beautiful Earth, the most picturesque of all. Dark blue seas and oceans, light blue rivers and lakes, golden deserts, green forests and white snow plains. The one and only one live planet. And now you see the most expensive part of the Urania Museum exhibits. Over 200 kilos of stones of extraterrestrial origin. The planetarium's meteorite collection is the biggest such collection open to public in Russia. Here are 113 very real extraterrestrials. Weird shapes and melted sides are the toll for landing collected by the Earth's atmosphere. Daily, the mass of the Earth increases by 5 metric tons because of the meteorites falling. Of iron, stony, of stone and iron. Most of the meteorites are the shards of asteroids, but some of them got to Earth from the Moon or even from Mars. For example, this shard of Mars that weighs 5.2 grams before becoming part of this collection has covered about 60 million kilometers. The biggest of the meteorites are put together to make a picturesque hillock. The heaviest of them weighs 124 kilos. There is a belief that if you touch a meteorite and make a wish, your wish will come true.